Hello judges, so my name is Tirth. I'm representing team Better Ballers. So our problem statement number was 11. We have built a real-time crowd intelligence and early warning system. Its primary goal is to maintain high-density areas, especially major pilgrimage corridors and temples, and prevent disasters like stampede and other issues. So mainly in our website, we have mentioned 4 temples, that is Ambaji, Dwarka, Somnath and Pavagad. So coming to my main feature, which is not listed in problem statement but we have innovated it, that is taking live CCTV footage, counting number of people, sending it to our train model, which will give our corridor pressure index. That is the first part which is needed, and all the other details that will be extracted from it. Now suppose if we go to live feed here, after 2 seconds the live feed will be started. We are not able to find a proper video, so this is an example of it, that entry point and exit point will be marked of 2 frames, that is coming in the temple and going out in the temple. Total number of people will be counted and graph will be represented. Here you can see the number of people are being counted that are currently present, and you can see this graph is made. This graph will be updated after every 5 seconds, and then from it we can see the capacity, net flow and the percent of confidence, and currently it is safe as the number of crowd is less, so it can be marked as safe. Then if we go down, here is the intelligent integration, that we have integrated LLM model which will give the suggestions or the actions required to the 3 categories that I mentioned, that is first is police, temple trust and bus route. Now this is a special model that is called what if analysis. Suppose we can add like what if 10 buses comes at once, then it will generate a response like what protocols to follow, and our trained LLM model will give the reply that 4 persons should stand near the bus, 2 should be near the corridor, etc., as per the needed things. Now this is another feature that is called stress test analysis. Now if you click it, after 2 seconds you can see the status is being changed to critical and there are tactical directives that are given. Now if you click on execute force protocol, all 3 parts will be alerted on what protocols you have to follow. Suppose if you go to police, then they will be given instructions that immediately implement following things. They can accept it, and in the logs it will be mentioned, so you can know that they have acknowledged this information, and this is a shared dashboard, so everyone would be able to see what's happening. This is mainly to maintain transparency and coordination among the teams. Similar we go for temple trust as well as GSRTC bus, that bus should not go to depot, like not depart from depot or stop 3 kilometers before, and etc. So you can close this stress test analysis and go to number 4. Now due to unavailability of CCTV footages, we have used data sets which contain timestamp wise data of people coming in and people going out. Then this is our replay feature that works. Now if we click on replay, you can see that the flow which is happening, like before in stress analysis the rate was high, and as we closed it the rate goes down slowly. So here you can see the density throughout the way, that before it was high, then it's coming less. Then this is the data set thing that is giving predictions and the graph is being based on it. Now suppose let's try another temple. Let's head to Dwarka temple. Then if we, as soon as we click on it, the data set will start automatically running, as you can see, and the prediction scores are already coming out. Now the graph is being made. Currently situation is normal, as you can see. Now you see the situations will spike currently from 22 to 63. That means the situation is going to get critical. So for 2 seconds it suddenly switched to critical. That is real-time update and it's currently working completely. Similar, this is the replay system that works. As you can see, if we start replay systems, there are 7 timestamps recorded, and if we start, you can see one by one that before it was less, suddenly it spiked to 60. That meant critical section, and it's less. Now this is the same example. We can say that what if heavy rain comes, then protocol will be different for heavy rain, that close the gates, evacuate people properly, etc., during rains. So this is our model. We have implemented every single thing which was listed, that is replay mode, risk analysis, and there is stress test and proper graph, real-time update. We have fetched data from CCTV, that is video, and given to our model is giving out graphs, and whole thing is all connected. And yes, this can be easily implemented anywhere. So yeah, thank you.